Hello everyone, welcome to the Math Bender. I'm Adnan Zaidi, and in this session I will talk about patterns, specifically quadratic pattern. So before starting off, we need to know what a quadratic pattern or a quadratic sequence expression is. So anything that you see is in the form of x squared, for example 2x squared plus x, 2x squared plus 3x plus 4. So all of these are called quadratic because they have their maximum power of 2 on them. So any expression, any equation which has a maximum power of 2, we call them quadratics. So this lecture is more specific towards the pattern learning. So I'll straight away hit the target. So let's look at a question here, and as you could see, this is the pattern. The formula is already given. So 3n squared plus 10, and I am supposed to find out the first 5 terms of the sequence. So if I take out the first term, for the first term, my n is going to be 1. So 3, instead of n I place with 1, squared plus 10, which gives you 3 times 1 squared is 1 plus 10, which is equals to 13. For the next pattern, I will see that it's going to be n turns out to be 2. The same formula applies 3 times 2 squared plus 10, which is going to be 3 times 2 squared is 4 plus 10, which is going to be 12 plus 10, which is 22. Remember that I saw a lot of students making some mistakes. What they do is they multiply these two first, and they do it 6 to the power 2. This is wrong. For the third one, n turns out to be 3, and 3 times 3 squared plus 10 is equals to, so 3 to the power of 2 is 9, so 3 times 9 plus 10, and 9 times 3 is 27. 27 plus 10 gives you 37. So the pattern may look like something like this: 13 as the first term, 22 second, 37 third, and so on. You may find out fourth and fifth by plugging in the value of n as 4 and 5. Let's look at another pattern here. So if I have 3 over 5 n squared, now for the first term I can say n is going to be 1, and I replace this whole in it. So 1 as instead of n. So 3 over 5, 1 squared is going to be 3 over 5. That's your first term. So for the second term, n is going to be 2, and I replace 3 over 5. Instead of n, I replace with 2, which gives you 3 over 5 times 2 squared is going to be 4, which turns out to be 4 times 3 is 12 over 5. Just a quick reminder that if you look at it, this 4 only multiplies straight ahead. They don't multiply like this. This is wrong. For the third one, n is going to be 3 because n represents the number of that term. So if I'm finding out the third term, n turns out to be 3. Instead of n, I replace it with, so 3 over 5. Instead of n, I replace it with 3. And 3 over 5 times 9, 3 squared is 9, going to be 27 over 5. So if I write down the pattern again, I will get 3 over 5 as my first term, then 12 over 5 as my second, and 27 over 5 the third term, and you can find out fourth and fifth term by plugging in the values of n as 4 and n 5. So this is how you figure out or write down the 5 terms. So looking at a pattern here in these, we are to generate a nth term formula, out of which computation, this pattern is generated. So let's say just before starting off, a quadratic pattern is in the form, and we will take it by default, an squared plus bn plus c. Just remember this, where a, b, and c, we have to figure out. These coefficients I need to find out. So step 1, write down the pattern: 4 7, 12, 19, and 28. Now, step 1 is find their differences. So if I find the differences, 7 minus 4 is going to give you 3. 12 minus 7 is going to give you 5. 19 minus 12 is 7. And as you could see, 28 minus 19 is going to give you 9. Note that in our previous lesson, we saw all the pattern which had a common difference in all of them. But in this question, the first difference that you've taken down does not have any common number. So let's do another thing. Let's take another step 2 and take another difference. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is again 2. And you see that the difference is coming out to be common, which is 2. This shows that in the second step, if the difference is coming out to be common, then it's a quadratic pattern. And this is all you need to know. So for a quadratic pattern, this represents an squared term, this term. And how do you find out the value of a? So a is going to be, now remember this value, whichever value that is, you divide that by 2. So in this case, this value was 2 and I divided by 2 gives you 1. So my pattern becomes 1n squared. So the value of a, I plug in the value of a and it becomes 1n squared. Now step 3. Let's write down the pattern again. 4, 7, 12, 19, 28. And this pattern, now make another new pattern out of it. And I'll write down here 1n squared. And since this is the first term, I will write n as 1. And if I take 1 squared, I get 1. For the second term, now n is going to be 2. 2 squared gives you 4. For the third term, n is going to be 3 squared, which is 9. I'm just plugging it in this n as this. Now, and so on, so forth, I can take 16. Now, take the difference. 4 minus 1 is going to be 3. 7 minus 4, 3, 3, 3. And since the pattern direction shows that this is going to be 3 as well later on, if I had continued with the steps. Now, this is again coming out to be a linear. Now, which means bn plus c. This. So, bn means you know that this is the difference. So, the difference between these two is 0. So, these two is 0. So, b turns out to be 0 and hence 0n makes it 0. Now, the third thing that you need to find out is the value of c. And we also have discussed in our previous sessions that the value of c or the number will be the first term minus the difference. The difference was 0 and 3 minus 0 becomes 3. So the pattern here is going to be an squared plus bn plus c, which is now going to be 1n squared plus 0n plus 3. So since 0n means nothing, so n squared plus 3. Now, let's check. So for the first term, n was 1. So 1 squared plus 3 is going to be 4. And you see that the first term was 4. Then for the second term, 2 squared plus 3 is going to be 4 plus 3, which is going to be 7. And as you could see, the pattern is generated. So the formula is going to be n squared plus 3. Now, if I have to find out the formula to generate this kind of a pattern, and knowingly, let's say if we don't have any, we don't know which kind of a pattern is it, then what we do is, now So step 1, let's look for the pattern if it is a quadratic or no. I'll write this pattern again. -4, 0, 8, 20, and find out the difference. So once I find out their differences, as I could see, 0 minus -4 makes it +4. 8 minus 0 is going to be 8. 20 minus 8 is going to be 12. So the difference is not constant, not same, which means there is a variation in the difference. It's not a linear pattern, it is a quadratic, and hence it is going to be in the form an squared plus bn plus c. Now to find out these a, b, and c, the values, I need to take a difference again. So 8 minus 4 is 4, and 12 minus 8 is again 4. Now this value will identify what is going to be my a. And a is going to be whatever this number becomes, is going to be this over 2, which is going to be 2. So I can say my first term here, this one, is going to be 2n squared. Now, after finding the coefficient for n squared, I rewrite it. So let's rewrite it. Rewrite the pattern. So after rewriting it, I'll write this as -4, 0, 8, and 20. And since I had an squared, which is going to be, I'll write an squared, which is now going to be, since I found out the value of a, which is now going to be 2n squared. And I remake another new pattern with n being equals to 1 in this first slot, n equals to 1 in the first slot. Now if I place n as 1, and n squared means 1 squared makes it 1, 1 times 2 is 2. Now for the second term, n is going to be 2. So as you know, this is the second term, and n represents in that number of particular term. So n squared is 2, 2 squared is 4, 4 times 2 makes it 8. The same way, if I keep on plugging these values, I will get 18 and 32. Let's take the difference. Once I take out their differences, this will become -4 minus 2 is going to be -6. 0 minus 8 is going to be -8. 8 minus 18 is -10. And 20 minus 32 is -12. I found another new pattern. Now, step 3. Take their difference again. So, -8 and +6. This is going to be -8 minus -6. It's -6, which is going to be -8 plus 6. And hence this pattern is going to have a difference of -2. These two, it's going to be a decreasing pattern of -2. And we already know that if it's a linear pattern having a constant change, I'll write this as -2n. And from this term, I subtract the difference. So -6 minus -2 is -4. Hence, my final formula is going to be 2n squared minus 2n minus 4. Now, if you want to test on the pattern that you already have, so this one, you can check n is equals to 4 here. So if in this formula, I place n as 4, I should be getting 20. Let's place it down. So 4 squared minus 2 times 4 minus 4, which is going to be 16 times 2, 2 times 16 minus 2 times 4 minus 4, which is going to give you 32 minus 8 minus 4, which is going to be 20. That's proven. Let's take another example here. So I write the pattern again, and that is my step 1 to identify whether if it is a quadratic or no. So I'll take the difference. This will be 7. This is going to be 13. And this is going to be 19. Since there is a change in the pattern, so I'll take another difference, which is going to be 13 minus 7, which is 6. 19 minus 13 is 6. Now, as I've mentioned previously as well, that this value identify what is a going to be. So a is going to be 6 over 2, which is 3. Now, step 2, I rewrite the pattern 0, 7, 20, and 39. And I write an squared, which is now 3n squared because a is now 3. Now placing the value of n as 1 in the first term, I get 3. Placing the value of n as 2 in for the second term, so 2 squared makes it 4. 4 times 3 is 12. Placing the value of n as 3, 3 times 3 is 9. 9 times 3 becomes 27. And placing the value of n as 4, 4 squared is 16 times 3 is 48. I take the difference. 0 minus 3 is minus 3. 7 minus 12 is minus 5. 20 minus 27 is negative 7. And hence I can correct the pattern. It's actually decreasing every 2 units. Now, since the decrease is constant, I can straight away say that it is going to be minus 2n. So this pattern is going to be minus 2n. And from the first term, I subtract minus 2 again. So minus 3, I'm doing that working here. Minus 3 minus minus 2. This is going to be minus 3 plus 2, which is going to be negative 1. And hence, I found another pattern using this. All I have to do is final step. This and this, I combine both of them and write them together. So 3n squared minus 2n minus 1. This is going to be the quadratic formula which is generating this original question, which was the pattern. You want to test it for n equals to 4, because this is the fourth term, it should give you 39. So let's try doing that. So 4 squared, I'm placing n as 4 minus 1. You want to try this out. So 3 times 4 squared minus 2 times 4 minus 1, which is going to give you 39, and hence the pattern is correct. Until my next video, take care. Bye bye.